All right, so we're getting started on chapter 10 today. Today's section is technically section 10.1, but it actually has a little bit of section 1.8 mixed into it, which we skipped at the beginning of the year because really it's review. And so I would recommend if you, kind of as we're going through, if you don't recognize some of these formulas that we've done, a couple of them are new, but some of them like rectangles and triangles should be pretty familiar and stuff that you've seen before, and I believe circles as well. So I'm going to give you all of the formulas today, but if you need a little bit more support, I would recommend maybe go back and look at section 1.8 in your textbook or look up some area and circumference and perimeter videos on Khan Academy. All right, so our first topic that we're working on today is remembering the area and perimeter of rectangles and triangles. So this should be pretty much review, but what I am going to do is make sure that you guys have formulas for everything today. And I'll put a cheat sheet of kind of all these formulas that I'm giving you at the very end of the video if you want to put them all in the same place, or you can kind of write them down as you go, it doesn't matter. So recall that for the rectangle of a perimeter, it's 2 times the base. So you're basically taking the base and just adding it together twice, and then taking the heights and adding them together twice. And then for the area of a rectangle, we do base times height. And then for a triangle, obviously we just add them all together. Remember that the perimeter is just the outside of a shape. And then the area of a triangle, it's technically, if you can imagine, it's half of a rectangle. So we do the base times the height, that finds the rectangle area, and we just cut it in half. So it's 1/2 base times height for the perimeter. If you're feeling really confident, go ahead and pause the video right now and just try out these 3 problems. I normally do this as a do now, but obviously we're not in class, so you can try them out. Otherwise, I'm going to go ahead and just kind of start talking through them here. So number 1, the rectangle, we're trying to find a perimeter here. So you could just write 4 plus 10 plus 4 plus 10 all the way, which that's actually what I tend to do. Or you could do 2 times 10 plus 2 times 4, which is the exact same thing. You should get 28 inches. And then for the area, we're just doing 4 times 10 base times height, right? So we get 40 inches squared. And technically, I guess it should be 10 times 4, but multiplication can go in any order. On number 2, if we want to find the perimeter, we need to figure out what this length here, C is. Sorry, I'm getting a little ahead of myself here. But you can either use the Pythagorean triple, 5, 12, 13, or just go back to our old-fashioned Pythagorean theorem, which is a squared plus b squared equals c squared, and solve for that missing hypotenuse over there. So if you notice in a triangle that you're being asked to find the perimeter, and you don't have all the sides, see if it's a right triangle. I'm pretty sure most of the ones in your homework tonight, if you do have a missing side, you'll be able to find it with the Pythagorean theorem. So once you have all those sides, 5, 12, 13 should equal 30 inches all the way around. And then our area formula obviously is just going to be 1/2 of the base times the height. So a lot of students will ask me, like, just kind of to remember, how do we do multiplication when we multiply a bunch of things in a row? I usually just go in order. So I say, okay, what's half of 12? That's 6. And then 6 times 5 gives me 30. For number 3, for the perimeter, we obviously just take 11, 9, 5, add them together. We should get 25 meters. And then for the area, notice that our base here is 5 still, but the height, which has that nice 90-degree angle, is actually 8 meters. So when you're looking at height, you always want to look at the side or kind of the dashed line that has a right angle. So your area is actually going to be 1/2 of 5 times 8, which gives you 20. One thing I want to point out too is that notice that the perimeters are all in just single units, so inches here or meters over here. And then the areas are always in inches or meters or units squared because we're talking about an area, right? We're kind of talking about all this space, and we have to multiply 2 numbers together to get that area. So area always has inches or units squared, and then perimeters always just have a single unit on them. Okay, so a quick exploration with rectangles. This is going to lead us into our next formula. This is the rectangle that was number 1 on the last slide. We're going to cut off a triangle from one end. So I imagine if I was doing this in person in class, I usually take a piece of paper and actually cut this off in class so you can see. But this we'll have to do for now. So I cut a triangle off of this side of the rectangle from one corner kind of into the middle over there. And then I'm going to slide it from here over to the other side. Okay, so in class, I always ask these questions. What type of new shape are we looking at over here now that I've moved that triangle over? And then what's the height of our new shape and what's the base of our new shape? So if you look at this shape, this is actually a parallelogram, right? So we still have these two sides that we know are parallel to each other because it's a rectangle. And then this shape and this shape are going to be also parallel to each other because we've got these same angles going on right up here, kind of these alternate interior angles. So this line and this line are parallel, it's a parallelogram. The height and the base are actually exactly the same as the rectangle, right? The height is still a 90-degree angle, and so it hasn't changed from what the rectangle height was over here. So that's important for the area of a parallelogram. The area of a parallelogram is actually exactly the same as a rectangle. It's literally the exact same formula. The area is equal to the base times the height. The only difference is that the height usually is going to be inside your parallelogram, right? Because it's kind of like that rectangle that we've sort of shifted the triangle over. But other than that, pretty simple, pretty close to, well, it is exactly the same as being a rectangle. Okay, so our first official example here is that we're looking at parallelograms now. So I'm kind of moving our way through our learning target. We did rectangles and triangles. Now we're hitting parallelograms. So the first example is this parallelogram here. Remember that we want to find the base and the height to find the area. And so my base here is clearly 5. The height has to be that line that goes down the middle there with a 90-degree angle. The height is not 4.5, right? Imagine if we were doing a triangle, right? 4 would be the height of the triangle. So get those other pictures in there. So my base is going to be 5. My height's going to be 4. Area equals base times height, multiply them together, you get 20 inches squared. On example B, 1B, our base is actually now going to be 8 feet, right? So this 8 feet is the height, and then this 8 feet is the base. It's kind of turned on its side. So our area is going to still be base times height, so we're going to get 64 feet squared. And notice that I'm still putting my units squared at the end there for my answer. One thing students ask often too is, do I have to write formula every time, area equals base times height? I'd say no, you don't have to do the formula, but I do want to see your work, right? If you're writing base times height, you need to write out 8 times 8 or 5 times 4 or whatever your formula is. You need to write it out with the numbers filled in. On example C, our new base here is actually 2, and then the height is outside of our parallelogram here at this 3.5 centimeters piece. The height is not 4.6 because that's kind of the diagonal length, right? Think about this triangle that's here. The height of that triangle is 3.5. So base is 2 centimeters, height's 3.5. So again, base times height, and you should get an area of 7 centimeters squared. So example 2, I wanted to just show you guys finding the area of a triangle when we have kind of this outside height here. Technically, 4 feet is still the height of this triangle. So think about what's the base of this triangle. It tells us that we have 2 feet here and 3 feet here. But if I was going to use 2 plus 3 and make the whole base of this triangle 5, that would actually find like everything inside this triangle, including this blank space here. So I'm actually just going to do 2 times 4 and then divide it by 2 or multiply it by a half. So my base is actually just going to be 2 and my height's going to be 4. 1/2 base times height, so 2 times 4, and your area should just be 4 feet squared. If you're not super confident or you're not really believing me that this could just be 2 times 4 base times height, you could go ahead, just take a minute now and find the area of the whole entire triangle and then subtract this white triangle here and see if you still get the same thing, right? Because you actually should still end up with the same thing. Okay, so moving on to circles. Just a quick reminder, this should be review, but the radius is half of the kind of width of the circle, if you will, here, and then the width of the circle is called the diameter. And so we say that the radius, r, is equal to half of the diameter. So you can see up here, right, the radius goes from the center to the edge, and the diameter goes from one edge to the other edge. So here are quick circle formulas. There's a couple of different ways to write the circumference formula. And remember that circumference is kind of like the fancy word for the perimeter of a circle. So the circumference, we either say 2 pi r or pi times the diameter. At Kent Ridge, they tend to like to teach it with the 2 pi r so that you only have 2 formulas that have the radius in them. and you don't have to have some random formula with the diameter in it. But when I was in middle school, I learned pi times the diameter and then pi r squared. So whichever one of these formulas you want to use, 2 pi r is the same thing as pi times the diameter, because if I multiply the radius by 2, it just gives me the diameter, right? So kind of pick and choose which one you want here. But for the area, we do pi times the radius squared. So we say that's pi r squared. So example 3, we're going to find circumference and area. So here's our first circle. So keep in mind here, this going from one end to the other, that's the diameter. If we want to find the radius is just going to be half of that. So our radius here is 6 centimeters. So to find the circumference, I'm gonna stick with the 2 pi r formula just because that's kind of my, in my muscle memory of my brain. So it's going to be 2 pi times 6, but you'll see at the end that we just end up with, well, 2 times 6, it's just 12, right? So really, if you want to do pi times diameter, that's fine. But keep in mind that when we write our final answer, pi goes at the end always. So we always put just sort of our normal regular integer or decimal number at the beginning, and then pi goes at the end. Notice also that we're leaving our answers in terms of pi. That means that we're not going to multiply pi out. So I'm not going to say 12 times 3.14 or type the pi button in my calculator. I'm just going to leave it as 12 times pi. That's my final answer. For the area, we're going to use pi r squared. So since our radius is 6, we're using 6 squared, so that's 36 pi centimeters squared. And notice because it's area, right, and because we had our radius squared, we're going to do centimeters squared units there. On the second example, excuse me, we're going to use 1.3. This is actually our radius, right? So one of the nice things about using the 2 pi r and the pi r squared is that once you have the radius, that's all you need, right? So since we have the radius for the circumference, it's going to sort of multiply, it's going to double the diameter or double the radius to find the diameter for me within that formula. So 2 pi r would be 2 pi times 1.3. Well, 2 times 1.3 is 2.6, so my circumference is 2.6 pi centimeters. And again, we're leaving it in terms of pi, so that's my answer. That's where I'm going to stop, and I'm not going to keep multiplying with 3.14 or with my calculator button for pi. The area, we're just going to plug in 1.3 for radius, so pi times 1.3 squared. That's 1.69, and then we just put the pi on the end and centimeters squared. Okay, so example 4 asks us to find the area of the irregular figure, and you might also see this written as in your homework, like as a composite figure or something like that. But basically what you see here is we've got this kind of like square triangle combo going on. So what I try to do most of the time is just think, okay, I have a lot of formulas already, right? Can I split it into something where I have 2 shapes that I know for sure? Because we don't have some kind of a formula for this like pentagon type of shape that we're looking at here. But we do know that we have a formula for a rectangle, and this rectangle is a special type of rectangle because it has 4 congruent sides. So this rectangle is a square, right? So we have all the sides are 6 inches. And then we have a triangle up here. Well, we know the areas for rectangles and for triangles, so we can do that. So the area of the square or rectangle, it's a type of rectangle, right, since it's a square, is going to be 6 by 6, right? The base is 6 inches, the height is 6 inches, and so our final area is going to be 36 inches squared. And yes, I probably should be a little more specific and say 6 inches times 6 inches, but just trying to show my work enough that I can follow it. So we found the area of the square right there, so we need to move on to that triangle. I'm going to just sort of redraw it over here. We have the height of our triangle already, but we need the base. And so the base, since it's just one side of the square, is just going to be 6 inches. So we have our height right here, our base right here, and then we just know our sort of normal area of a triangle formula is going to be 1/2 6 times 8, and that's 24 inches squared. By the way, one thing I didn't mention earlier is that I've noticed a lot of students who learn this in middle school write this formula as 6 times 8 divided by 2. So you might write it as like this, 6 times 8 divided by 2, and it should give you the same answer. I'm not sure why. I mean, obviously it makes sense, right? We're saying 1/2 or divided by 2. But I'm not sure why different kind of classes teach it differently. So whichever one works for you, you basically just take the base and the height and divide it by 2 or cut it in half somehow, right? So we should get 24 inches squared there. So now that we have 24 inches squared and we have 36 inches squared, all we have to do to find this total area is to just add them together, right? So the total area is we add the triangle plus the square, and that gets us a total of 60 inches squared. Your assignment today is to do the 1.8/10.1 worksheet, which will be attached in Teams. Thank you.